And here's our final tutorial. In this final tutorial, we will determine which exponential functions are growth and which ones are decay. So this is a pretty simple skill to have. When you're looking for growth, all you need to find is a base that is greater than 1. And when you're looking for decay, you're looking for a base that is less than 1. We don't have any bases that are equal to 1 because those are kind of boring functions. The only thing you need to make sure is true is your exponent must be positive to be able to determine what the value of the base is, whether it's greater than or less than 1. So I have 9 examples here, and actually what I'd like for you to do first is pause the video when I'm finished with my statement here. One of these 9 is actually not belonging. It's neither growth nor decay. It's the one that is different from all the other ones, and I'd like to see if you can spot that. So if you would please pause right now and see if you can figure out which one of these 9 is not like the others. Pause now. So I hope you were successful with that one. We're talking about part D. This is the one function that is not like any of the other ones because we have a negative value for a. This is like a negative 1 times 10 to the x power. And when you have a value of a that is negative, then we don't call that either growth or decay. In fact, we would just call that neither. Okay, now we're going to figure out which ones of the other 8 are growth and which ones are decay. Before I do that, I'd like to make sure all of my exponents are positive. This first one is positive, the second one is positive, the third one is positive. We don't care about the neither. Uh-oh, here's my first one in part E where the exponent is not positive. So what I need to do is rewrite this base so that it does have a positive exponent. And to get rid of the negative basically means to take the reciprocal of the base. So really we're talking about 4/3 to the positive x. These are identical things, but we need the exponent to be positive to determine if we have growth or decay. F is positive, G is positive, H is positive. Oh, and here's our last one. We have another negative exponent, so we need to rewrite this one by flipping the base to 2/3 and making that a positive exponent. Now that all of our exponents are positive, we just need to look at the base and see which ones are greater than 1. Those would be our growth. So since 4 is greater than 1, that's growth. Let's find another one. 1/5 is not greater than 1. E. If you don't know the number E yet, E is approximately 2.71828. So that is obviously a number that's bigger than 1. So E is bigger than 1. This must be growth. This is a neither. This looked like it was going to be a number that was less than 1, but when it's in a positive exponent rewritten as that, we see that 4/3 is bigger than 1 because the numerator is bigger than the denominator. So that's going to be a growth. 5/3 is actually even bigger than 4/3. Either way, they're both bigger than 1, so that's a growth. Let's look, 0.5, that's less than 1. Pi, we all know, is approximately 3.1415, so that is going to be bigger than 1, so that's a growth. And our final one, 2/3, nope, that's going to be less. So all the other ones must be decay. Here's a decay because the base is less than 1. Here's a decay because the base is less than 1. And our final one, 2/3. Again, tried to trick you here, but you base that we have to have a positive exponent before we can determine this. 2/3 is less than 1, so that would be a decay as well. So pretty simple topic. Make sure your exponent is positive and then determine if you have growth or decay. And watch out for the one that might be neither. That's when A is negative. No good for that. Thanks. See ya.